All right, so let's take a look at a couple of questions from the 7.7 homework quiz to kind of help some of you out. Seen from your results, some of you are kind of struggling on where to place values. Keep in mind, 7.7 is determining whether or not you're dealing with exponential growth or exponential decay or compound interest, and then setting up the correct equation accordingly. And then really, after you have the equation set up, you can plug the entire thing into a graphing calculator or a regular calculator or Desmos if you need to. So let's just look at a couple of these. So for question 1, it says the number of students enrolled at a college is 15,000 and grows 4% each year. Because they're talking about growth here, this is going to be exponential growth. So our initial setup is going to be y equals, in this case, y equals a times 1 plus the rate raised to the time power. So a is the initial value, so that's your 15,000. So a, your rate has to be turned into a decimal, so this is 0.04 is the rate, and then the time, they say, is 25 years, so t is 25. So we're just plugging in this information. So we've got y equals 15,000 times 1 plus 0.04 raised to the 25th power. So now ideally we can plug this into Desmos and it should give us our answer. And remember, we want to round our answer to the nearest whole number or whole student. So that part I'll leave up to you. I'm not going to give you the answers just yet. So if we go down a little farther, we're going to see a problem here. It says find the balance for each of the given, or with each of the given following information. So we're now looking at question 3. So we looked at question 1 and 3. Here, this is going to be a compound interest question. So the natural setup for this should be, it's going to be such that you have your actual equals your principal times 1 plus your rate divided by how many times it's compounded, all raised to the n times t power. So it would be the number of times compounded times the number of years. So for this problem, let's pick apart what we need to know. Well, your principal or your initial value is $500, so this is P. We know the rate is 4%, so that's 0.04, so that's N. Or sorry, that's R. Oops. Compounded quarterly, there are 4 quarters in a dollar, so N in this case is 4, and then T in this case equals 6. So we're going to plug in all of this information. So naturally we know in this case that A is going to equal the principal, 500 times 1 plus the rate, so that's 0.04 divided by 4, because the number of times compounded, raised to the, in this case, 4 times 6 power. Okay, and if we want to simplify this, we can go A equals 500 times 1 plus, 0.04 divided by 4 raised to the 24th power. And so ultimately, if we plug this into Desmos or our graphing calculator, it should give us the answer we need for this problem. Keep in mind you're rounding to the nearest cent. Let's look at one more compound interest problem. So let's look at 5 down here at the bottom. It's a little hard to see, but same idea. It says find the balance of each given the information that follows. So we've got 12,000 as our principal. Our rate in this case is going to be 0.048 because we have to move the decimal place 2 places. And then T is going to be 7. And this time it says compounded annually, so that's 1 time a year, so N equals 1. So now that we have all this information, we're going to plug it in. So we've got A equals, in this case, the principal is 12,000 times 1 plus 0.048 over 1, and then to the 7th power. 7 times 1 is 7, so we can leave that alone. So this is what we're going to put in our calculator. And if we've done it right, we should be getting our answers accordingly, but that part's up to you. I'm helping you with the setup. That part's up to you. All right? So the only other thing to talk about is what happens when we see an exponential decay problem. Well, they look just like question 1, except instead of the addition in between, you would see subtraction. So keep that in mind. For decay, you're seeing subtraction. I don't have one on this screen right now, but keep in mind if it's talking about exponential decay, that's what you would do. So I believe there's a problem on your homework quiz that talks about exponential decay dealing with a city. So if I can remember off the top of my head, let's take a look at that. So I'm going to kind of get rid of some of this stuff so I can take a better look at it, because I don't have it on the screen right now. But this should help you. And so essentially we'll have half of the problems taken care of setup-wise for the homework quiz. So the rest of it's kind of just up to you recognizing patterns. So on the homework quiz problem, I believe it talks about the population of a city. Starts at 45,000. And it is decreasing by a rate of... It's decreasing by a rate of 2% each year. So 2%. Each year, and they want to know what the population will be after 15 years. 15 years. So this problem is exponential decay. So we're looking at y equals the original amount, and then 1 plus, or sorry, not 1 plus the rate. Since it's decay, decreasing, 1 minus the rate times time, or raised to the time power, sorry. So in this case, your rate is going to be 0.02. Your A value in this case is just 45,000, and then your time is just 50. So if we know that 45,000 is A, it's decreasing, rate is 0.02, and then time is 15, we're going to plug all this in. So we've got 45,000, and then 1 minus 0.02 raised to the 15th power. And like before, if you plug this in with the parentheses and everything else into Desmos or a graphing calculator, it will give you your answer. And I believe in this problem, they want you to round to the nearest person. So make sure you're rounding correctly, and you should be okay. Go through the homework quiz. You have multiple attempts. If you have any other questions, make sure you send a Schoology message.